everyone, welcome to video 2 from lesson 6-5 in pre-calculus, the law of sines. We just finished discussing the ambiguous case, and that's where they give you two sides and the angle that's at the end here. We talked about how with sine functions, you will get two different angles at the top here. So now let's look at some examples to see how that works out in practical terms. In example 3, they want us to solve triangle ABC, where angle A is 45 degrees, side A is 7 times the square root of 2, and side B is 7. But notice they haven't given us a triangle. That's a big problem for us. So the first thing that you're going to do is you're going to try and draw this triangle, where angle A is 45, side A is 7 square root 2, and side B is 7. So pause the video, do that, and then press play, and I'll talk about the next step you need to take. Okay, so I have my triangle here. Remember, angle A is always across from side A, so that's how I knew how to place those. And angle B is always across from side B. So it's very important that you're careful with your labels when you draw your triangle. Okay, so this is my triangle. Now let's talk about what you should do first. Notice we have enough to start a law of sines proportion. Sine 45 over 7 square root 2. Now, for the C's, we don't have a single measurement there, so we can't use those yet. So we're going to do B and AC. So I'm going to do sine B over 7 to make my proportion. And then I'm going to solve it. So watch what I have here. Let me just move my rectangle a little. There we go. Okay, so the sine of 45 over 7 square root 2 equals sine B over 7. I did a cross product. 7 sine 45 equals 7 square root 2 times the sine of B. Now remember, sine and B are basically like attached. You cannot just divide by sine because it's supposed to be sine of an angle. So hopefully this is the triangle that you got. Now notice that side C is always across from angle C, and side B is always across from angle B. So that's how I knew where to place these letters and the numbers that correspond to them. Now you can turn this triangle on its side, and that's okay, as long as you're sure that side A is across from angle A, side B is across from angle B, and side C is across from angle C. Now we're going to start off, notice we have both pairs of A measurements, and that's important. So that makes a fraction for our sine, our law of sines. Now I can't use C's because I don't know either the angle or the side, and it's really important to know one of them. So I'm going to have to do side B and angle B. So that's where you're going to start, is to solve for angle B. So here's the proportion that I made. Is and how I solved it. So it was the sine of 45 over 7 square root 2 equals the sine of angle B over 7. Now I did a cross product. 7 sine 45 equals 7 square root 2 sine B. And then what I did is I divided by the 7 square root of 2, and to get the B away from the sine, I had to do an inverse sine there. And that's how you find an angle measurement using trig functions, is you use an inverse trig function. So I did the inverse sine of 7 sine 45 over 7 square root 2. That comes out to be 30 degrees. Now, you may recall that sine of 45 is one of the ones that we know from our unit circle. That's square root 2 over 2. So this is 7 square root 2 over 2 divided by 7 square root 2. That comes out to 1/2. And the inverse sine of 1/2 is 30 degrees. Now, we're not done there because, remember, this is a law of sines question. We have to double check to see if there's another option for this. Anytime you use the law of sines to find an angle measure, you have to double check 180 minus that measurement to get another angle. Now, this angle, 150 degrees, actually will not work because with this 45 degrees in there, 45 plus 150 is 195. That's way too much for a triangle. Remember, a triangle's angles add to 180. So this is not going to work. The 30 degrees is the only possible measure for angle B. So what you're going to do is you're going to solve for angle C using the two angles that we know, and then you're going to find side C using the law of sines. So pause the video and do that, and then press play to check your answers. So for angle C, I did 180 minus 30 plus 45, which is 105 degrees. So angle C is 105 degrees, and I don't need to find a second option because I didn't use an inverse sine. So I'm okay with 105 degrees. Now to find side C, I'm starting out with the same fraction I used at the beginning, because just in case I calculated something wrong with my b's, I won't have to use that wrong measurement again. So sine 45 over 7 square root 2 equals sine of 105 over c. And we're going to solve this using a cross product. So 7 square root 2 sine 105 divided by the sine of 45. And again, you just want to be very careful how you type this in. You might want to do it in several steps to make sure that it's not grouping things in a way that you don't want it grouped. But I got 13.5 for that. So we're going to do another example next. In example 4, they want you to solve triangle ABC if angle A is 43.1 degrees, side A is 186.2, and side B is 248.6. So start off by drawing the triangle and trying to decide what you should solve for first. So this is the triangle I made. Notice that the A's again are given to us, and we need to find B's and C's again. So in my plan, I said, well, the A's are given, so that's going to make my first fraction in my law of sines. And the B's, I have a side, but not an angle. So that's going to be my second fraction. Again, I can't use the C's because I don't know either the side or the angle. So try and solve for angle B. Pause the video. Try and solve it, and then press play and check your answer. So for angle B, I found out that I could get 65.8 for one angle. Now, remember, we always check both angles. I would do 180 minus 65.8 to get 114.2. And both of these are actually possible because 114.2 plus 43.1 is not more than 180. It's not equal to 180 either. So it does work. It can create a triangle. So we need to do both options. So option 1 is 65.8 degrees for angle B. So find angle C and side C for that. So with angle B at 65.8, I found out that angle C is 71.1. I just did 65.8 plus 43.1, and I subtracted from 180. Next, I used the law of sines to find side C. So I took that same fraction that I started with up here, sine 43.1 over 186.2, sine of 71.1 over C, and I solved for side C. I did 186.2 times the sine of 71.1 divided by the sine of 43.1. And that should come out to 257.9. So side C is 257.9. Now what you're going to do is you're going to pause the video and find out the other option for 114.2 degrees for angle B. So try the other option and solve for angle C and side C again. Okay, so with angle B at 114.2, angle C was 22.7. Okay, so now I'm going to do my proportion again. And I did 186.2 times the sine of 22 divided by the sine of 43.1 to get 105.2 for that last measurement. All of these are options, so I'm going to have two different triangles I can give. The one with these measurements, the 71.1 and the 257, and angle B is 65.8. And this one with 114.2, 22.7, and 105.2. Okay, we have one last example. It says solve triangle ABC where angle A is 42 degrees, side A is 70, and side B is 122. So what you're going to do is you're going to try to make that triangle and try to solve for angle B and see what happens. Then press play to check to see what is going on with this triangle. So notice, here's my triangle. 42 is across from 70, so I did sine 42 over 70. And angle B is across from 122. And this is what I got when I tried to solve it. But you get an error message when you put it in. This fraction right here is equal to 1.17. Now remember, the domain of the inverse sine function is from -1 to +1. This is outside the domain of this function, so this cannot make a triangle. It's not possible to have a triangle with these measurements. So that's the last example for this lesson. Please make sure that if you have any questions, you let me know what they are.